Hello, I'm James Ingram for AutoControls-dot-org. In this video, we'll show the automatic control of two N-gauge trains running on a single main line. Note this is a continuation of previous video 827, where we operated three N-gauge trains on this same layout. If you ever try this, you'll probably want to try the two-train system before you try the three-train system, which is why we're making this video. And what we're using an NCE power cab and an NCE Mini-Panel to do the automatic control. And the NCE Mini-Panel, if you're not familiar with it, is a relatively simple off-the-shelf programmable train controller that costs around $49. And people seem to freak out, model railroaders seem to freak out when they hear the word program, but this stuff's very elementary. And in fact, I'd ask you to stop and think about it. We should probably teach elementary school kids to do this kind of programming. Consider if you put these mini panels in elementary schools and let the elementary school kids program them, it might give them an interest in technology. You might want to use a larger scale train, like a large scale or an O gauge, but it might be interesting for kids to do this. Thanks for watching. I'm going to push the push button here, which, if this was a public display layout of some sort, this button could be presented to the public, and when they push it, as I'm doing now, it'll start the train up. Notice that yellow train that started up was sitting over there near where that piece of track was, and this should execute a single cycle and park right back where it was. Notice the red train is parked back at the station, kind of in the left rear where the yard sign is. There's a red PA Elko back there parked. And when this yellow train that's moving on the main line passes in front of that detector, which is down in the far right corner, you can probably see that'll change the green from green to red, which will indicate the detector has sensed the train. There it goes. And when that happens, the mini panel, which is our controller, will start up the red train. It'll execute a delay statement of about 15 seconds, which brings the yellow train into the station. Now the yellow train will sit there and wait until the red train passes in front of the detector. Again, we call this mode of operation single cycle because it'll run just one cycle with a short delay. I use the term short delay because we're using the minimum amount of delay that we need to get the train past the detector up to the yard. We have to pull it up as far as it is now. I mean to say that that's the yellow train. We've got to pull that up as far as you see it now, just about to have enough room for it to get started when that red train comes in. You can see they're only about 18 inches apart until the yellow one gets going, and you probably wouldn't want to run them any closer. Now you can see they stopped right back where they started. This is what I call a single cycle. And again, these will wait here for 5 minutes or however long. They'll sit there and wait until somebody comes along and pushes the button again, and then they'll start out a second time. Now we're going to start out the same way as before by pushing this red button, which will start the yellow train up just like before. The only thing different we're going to do is I'm going to step over to the control panel and close this switch that I call the repeat switch, and that'll keep the trains, that'll keep them to repeat the cycling of one train running, then the other train running, instead of stopping after one cycle. Now again, that red engine will sit there back at the station until the yellow engine crosses in front of the detector, at which point the mini panel, the controller, will start the red engine up, and it'll slow the yellow engine down to speed 6. and it'll execute a delay statement of 10 seconds long. I misspoke in the first demonstration. I said 15 seconds. It's really about 10 seconds that it brings those trains up. And we're using pretty close to the minimum amount of delay. We have to bring that yellow train up far enough away from the detector so that when the red train comes into the yard, and when I say coming into the yard, I mean crosses a detector down there. When that red train crosses a detector and comes into the yard, the yellow train has to be far enough ahead of it that it has enough time to get started and not have the red train chasing it or bumping into the rear end of it. And if you watch, you can see there's about 18 inches of separation before the yellow train gets going. Now, if you see the yellow train coming up close to that piece of track up here, before that stopped there, because that's the end of a cycle, but since I threw that repeat switch, the routine that's running checked that, and it's executing the cycle a second time. So the same thing is going to happen all over again. And basically this gives you an effect that one train spends most of its time parked at the station while the other train makes a circuit of the layout, however long that may be. If it's a short layout, like in the previous video, 826, which showed 2 MTHO gauge trains running on a small loop, then it doesn't sit there very long. But this is a medium-sized loop, so the trains sit there for a minute maybe, or whatever amount of time it is taking these trains to run around the loop. Now I'll go over here, and this would keep running all day long if we left that repeat switch closed. What I'll do is go over here and I'll open this repeat switch. So the next time the yellow train gets started up, it should come up to this piece of track and stop again because the repeat switch is open. And again, I don't know if I mentioned that this is a repeat. This is the same hardware and everything that was used in the previous video, 827. We just took one of the trains off the track, the freight train. We removed that. And we moved the wire that this push button's connected to over to input 1 instead of input 2. Now there you can see the yellow train stopped, and both trains will sit there stopped and wait again until somebody comes along and pushes the button, and that'll start them up again. And as it is now, it would make one cycle, or if we close that repeat switch, they'll keep cycling continuously. Now we'll start these trains up again by pushing the red button as we did before, and we'll go over here and we'll close the repeat switch to keep them running, and we'll close this other switch down here, which I call the long delay switch, and that will increase that delay time from 10 seconds to about 30 seconds total. We'll add another 20 seconds of delay to the delay time. And when I say delay, when you tell the mini panel to delay for so many seconds, it just sits there and does nothing. So if these trains are running at a certain speed and you say delay for 10 seconds or delay for 30 seconds, that means the trains will go a certain distance, and then when that delay statement ends and you give it a stop statement or something like that, then the trains will stop or do whatever action you tell it to do. Now if you watch the yellow train, instead of stopping at the station there where it did before, it keeps running because it's got another 20 seconds of delay. And the mainline speed is running at train 8. I should have mentioned that earlier, but they're running at speed 8. And the yard train, which is the yellow one, is pulling up at speed 6. Now it'll stop about where that second station is there. So you can see the net effect is the train, instead of stopping at the rear station back by the yard sign, it kept running, and it pulled all the way up to this front station. And when the red train crosses in front of the detector, the same thing will happen with the red train. So, and again, our what we're calling our yard speed is speed 6. That's the red train right now. And our mainline speed is speed 8. Back in the previous video, 827 with 3 trains, we were using yard speeds of 4 and 5, but here we're running them a little bit faster. Now you can see the red train's going to come up and stop at the front station instead of the rear station. Now let's open the repeat switch. That means when the next time this completes a complete cycle, they'll park themselves again. These diesels, by the way, are Kato diesels with the factory installed ESU Loksound, and their stock as they came out of the box, except I changed the momentum from, I think it was 80 down to 50 because I needed them to start a little bit faster. And I changed one CB that controls the startup delay. These, as they come, they have a delay to sit for a couple seconds when you try to start them up to make them more prototypical, but I removed that by changing a certain CB. So they'll start up more or less instantly, which makes it easier for train control, automatic train control on a smaller layout like this. Now you can see they both stopped in their new positions, and you can flip these back and forth as you like from the short delay to the long delay, and they'll adjust on the fly. Let's start them up here. And we'll open the long delay switch, means we're going back to the short delay. And you can see the yellow one's going to come up and park at the rear station like before. And the red one, when it comes in, it'll park at the rear station like before. Now, since we're operating under the short delay and the repeat switch is open, when that red train comes up to the rear station, the mini panel will send stop commands to both trains, and you can see they're back in the original positions. Now we'll start these trains out from their normal position, and this time we'll demonstrate what I call the keep moving switch. In other words, it'll keep 2 trains moving all the time rather than one train stops at the station. So we'll throw the switch, it's out of sight down here, but there's a switch called the keep moving switch, which I just closed. And once that red engine gets started up, which again will happen as before when the yellow engine crosses in front of the detector, once that gets started up, instead of stopping it later, we'll just let it keep moving at a reduced speed 6. Now there's our detector has been tripped, or I should say triggered. Now the red train is running on the main line at speed 8 as before, but notice the yellow train, instead of pulling up to the station and stopping, it's running under speed 6, and I've got the short delay back. That is to say, the long delay switch is open. We don't want long delay when running in this mode. But now you see, instead of stopping at the station, it just keeps going, because we never send out a speed 0 command. We just let it keep running at speed 6. The red train is out running at speed 8. When that red train crosses in front of the detector, the mini panel will slow the red train down to speed 6, and it'll speed the yellow train up to speed 8. You may be able to see the yellow train speeded up a little bit and the red train speeded down a little bit. We've got to keep and they stopped here because the repeat switch was open. So again, it made a single cycle and stopped. Now I've moved the station over next to the yellow engine to indicate the new position when they stop, when a cycle ends. And we'll push the button to start them up again. And again, when the yellow engine gets to the detector, the red engine will be started up. And with the, I close the keep repeating switch, so this will keep running. This time it won't stop until we open that switch again. And we've got the red train is on the main line running at speed 8, and the yellow one is in the yard running at speed 6, but because we're in the two trains moving mode, it'll keep moving at speed 6 rather than shutting down. So notice that we'll have two trains running continuously until we open the keep repeating switch and they stop again. And we got the delay statement, as I mentioned. I think we've got the delay is back to the short delay. The delay has to end before the train coming into the detector, like the red one now. The delay statement has to end before that train reaches a detector. If the mini panel is still executing a delay statement and a train reaches a detector, it won't be detected and the system will be messed up. That's not obvious watching these trains running probably, but if you look at the programming, you can see why that's the case. This is a loop of Kato Unitrack, and it's running on a standard 30-inch wide by 8-foot long office table. And note we have like about 8 wires total to the layout, and there's no blocks. There's 2 wires for each of the power connections here, and then there's 4 wires going down to that Z-Stuff detector. That's a Z-Stuff model DZ1012 detector, and a Z-Stuff model DZ1000, I should say 1008 relay. And that could be a reed switch or another brand of infrared detector, or electric eye, or I think I said reed switch. It could be somebody sitting there pushing a button when it went past. Just anything that grounds the input 14 of the mini panel to tell it that the train is there. But the big thing is, besides the small number of wires, this layout has no blocks, and that detector is not even fastened to the track. It's just sitting next to it, so it's very easy to move the detector to a different position on the layout. And this is an NCE power cab, which is powering all this system. I'm going to switch the, I'm going to turn the sound on. That sound is on the Elko. Now the sound is on the E9. To see what they sound like with the sound on. I prefer the sound. Some people don't like the sound, but I prefer it. It makes it a little harder to talk when you're having a demonstration, which is why I turned it off earlier. But for normal operation on a display layout, I like the sound because I think it makes your trains seem like they're traveling faster when the sound is on than when they run without the sound, even though it's the same speed. I try to run these display layouts as slow as I can, that it doesn't look like the engines are running too slow, because the slower I can run the trains, effectively the longer is the main line. That Z-stuff detector, it throws out an infrared beam at about a 45-degree angle, which is how it detects when something goes by. When something goes by, it reflects that infrared beam back to the detector, and it can sense that because it's going up at an angle, it won't detect trains on an adjacent track. And notice this DZ1012 is oversized for N gauge. It's actually an O gauge detector, but I found it's short enough that it will pick up it'll detect an N gauge train. Z-Stuff makes HO, I believe, and Z-scale models of the detectors, but you have to drill a hole in your platform because the electronics are underneath of them. And since this is an office table, I didn't want to drill a hole in it. I wanted something portable I could move around. And the DZ1011 is a cheaper model of the DZ1012. It doesn't have the variable time delay, and that's probably what you would normally use. It's just I'm using the DZ1012 because it's shorter than the DZ1011. The DZ1011 would probably be too tall to pick up, that is to say, to detect an N gauge train, although it works fine with HO gauge and anything above that. Now we'll close let's open the repeat switch. Let's open the two train switch. So we'll go back to parking at the station now. You can see now the red train parked at the station. So we can switch back and forth between basically all these switches. The only restriction is, like I mentioned, when you're running in the two trains mode, you want the delay switch open. You don't want the longer delay for that. It doesn't do any good. And if you were running two trains all the time, that is to say you didn't want the station stop like we're doing right now, you could probably make the delay statement even shorter. The delay statement has to be long enough that when the train goes past the detector, the train gets completely past the detector, because once that delay statement ends, the Mini-Panel sends a few commands, and then it's executing what's called a wait statement. Wait until input 14 goes to ground. When it executes that command, it's waiting for that to be grounded. So you got to get the train past the detector before you start looking for it a second time. Now we'll open the repeat switch. And they should go back to parking in their normal position. There we are, so we're stopped waiting for the button to be pushed again. So you can use any of these three modes, the station stop with the short delay, station stop with the long delay, or the two trains moving, and still have this push button available for the public to push. Here's what I call the control panel. We've got the power cab over here, which is what's powering everything. We have the NCE Mini-Panel here, which is what's doing all the work of controlling everything. This is the power control panel, PCP, which is part of the power cab. If you use a Powerhouse Pro or something else, then you wouldn't have this. These are 2 push buttons. This 3 is the one for 3-train operation. This 2 is the one for 2-train operation. And this button is in parallel with this button here, so we can use either this one or this one, but it's set up so that if you don't have what I call the public button hooked up, you can start the trains by using this button for 2 trains or this button for 3 trains. And you wouldn't want to give the public both. You have to make sure you don't push the wrong button, because you'll have a wreck. If I push the 3-train button, I've only got 2 trains on the track, I'll have a wreck before too long. And likewise, you wouldn't want to give the public both buttons. You give them one or the other depending on how many trains you're running with this system. You could have another button on the back. This is set up for something else, but you can see if I flip this thing over, there's actually 2 buttons on the other side, so you could have another button here connected to the other input for like 3-train operation. And then as far as the rest of the stuff on the control panel, this is a reset button, which we use to reset the mini panel if we're doing something with it, or if we have to stop the trains in the middle of operation. Pushing the reset buttons forces it to quit. Then these 3 single pole, single throw switches are here. These are the ones we were referring to in the demo. This is what I call the repeat button. This is what I call the repeat switch, the more delay switch, and the 2 trains running switch. And they're wired so that if they're down, they're off, and if they're pulled up, then they're on. And these are just wired. This is wired, I think, the input 18. This is wired input 20, and I think this is wired input 24. But you can use really any of the inputs you want that's not already being used for something else. But this basically shows you, the idea is to show you the control panel of how all this is controlled and how I put it together. Not that this is the best way to put it together, but it seems to work. Now here we're going to try this 2-train operation. Note I give you the program such as I've written it. It's on the documentation site at AutoControls-dot-wordpress.com. Just look for video number 828 on that page, on that web page. And you might find a way to improve upon my commands that you like better. This is just something that works as you see it in the video. And this just consists of these, you say programming and people get excited about it, but it's simple commands like select loco 957, that's the one part there, speed forward 8, which starts it up to speed 8, speed forward 0, which stops it, the delay statement as we talked about, and the wait until an input is grounded statement that we talked about. Just simple commands that you can pretty much understand. At any rate, if you write a program like this and want to try it, you can test it with just 1 train. If you look at the layout, you can see the red train is over by the station, kind of where it was before, but it's actually off the track, alongside the track, so it's just the yellow train on the track now. So let's start it up as we would normally. I'll push the button. And that train has to start really anywhere upstream of the detector by at least a few feet. When the train crosses in front of the detector, it should ideally have gotten up to its cruising speed, and the momentum has been taken care of, so it's running at its normal speed. But it can start anywhere upstream of the detector. Now, when it crosses in front of the detector, as it usually does, it'll send a command, that is, the mini panel will send a command to start the red train up. But the mini panel sends that command. It has no way of knowing that the red train is not on the track. So it'll bring the yellow train in to the station and park it like normally. There we go, our delay statement ended. It sent a speed 0 command to the yellow engine, which made it stop and park. Now, if the red train was on the track, it would be out traveling around the main line, and in about 45 seconds, I think I tried to time it. It takes about 45 seconds for the trains to go around this loop. When the red train crossed in front of the detector, then it would start the yellow train up. But what we can do is go over here and just use our hand to simulate the red train, which I'll do now. I put my hand in front of the detector, which is the same thing that would have happened if the red train had gone by. So now the yellow train is traveling around the loop like normal, and the red train, if it was on the track, would be parked over at the station. If you look at the program for this, it's actually very simple. It's not like a self-driving automobile or a SpaceX rocket that's launching and re-landing. It's very elementary commands. Okay, the mini panel slowed that train down to 6, and it's executing the 10-second delay. The red train would be out on the main line at speed 8 if it were running. So again, we're right back at the same place as we were before. So again, if we go over there and put our hand in front of that detector, you can see putting our hand in front of the detector started that train up just like normal. So that's an easy way to test your program with just one train on the track. If you were using the red train and not the yellow train, we'd start the red train from its normal starting point, which is sitting over by the station where it is now, and we would put our hand in front of the detector to simulate the yellow train going in front of the detector if it wasn't on the track. And that would start the red train up. So you're just basically using your hand to simulate the other train passing in front of the detector. In the previous demonstration, we showed how we could run one train on the track to test our programming and use our hand, putting our hand in front of the detector to simulate the second train going in front of the detector, even though that second train, in this case the red train, wasn't even on the track. Now, one other adjustment we can make, we can go in and change one line of the program, replacing the statement that waits for the detector to be crossed with a delay statement, and that'll park the train at the station and wait for X number of seconds, and then the train will start up again. And looking at my, this is just my printout of my notes that show what the commands are that I put in this thing. You see the 9.2 here, that's input 9 step 2, and this wait till input 14 is ground statement. That waits until the yellow engine crosses it waits till the red engine crosses the detector, which releases the yellow engine. If we take that out and replace that with a delay 10-second statement, which is what I've done, then instead of having to go over and put our hand in front of there when one train is on the track, when that delay statement times out, the train will start itself back up again. So let's take a look at that now. We'll start the train as usual. And it's running the speed, running the main line at speed 8. There's other ways to control these trains also, just by way of mentioning, like JMRI and Arduino and the computer programs, train controller and iTrain, but the mini panel seems a lot simpler to learn, and plus you don't need to have a computer. It doesn't have the power that other stuff has. You can only use it for simple things like this type of stuff, but it's good for displays. Now we're running that 10-second delay just like normal, and that'll stop that train. Now instead of waiting for the second train or waiting for us to put our hand in front of the detector, there's a delay statement executing right now, which is about 10 seconds. And when that delay statement ends, as it just did, that train will start up and make another loop. So that one, I've got the repeat switch closed, so that one train will just keep continuously running like that. So if you had this as a display layout and you wanted to change from 2-train operation to 1-train operation for some reason, say one of your engines, you only had 2 engines and one of them conked out, just by changing one line of your program like we've done here, you could still have an automatic display with 1 train. Now we'll open the repeat switch. So it should go through that same cycle of events by the station. We're running under a 10-second delay to get that train up to the station. Now we're running under another 10-second delay to have it parked there. And when that delay statement ends after about 10 seconds, the local will come up and park in what was its normal starting spot. And that'll sit there and wait until somebody pushes the button again. Now, if you were working for just 1 train only, you never wanted to control more than 1 train, you could write a different version of this which would give you more flexibility to have the train run different laps. You could actually modify it to have the train run 3 laps and then stop and wait and then start up again and run 3 more laps. But hopefully you get the idea how you can do some modifications to test this thing with just 1 train. We're now at the end of this video. I plan to make in the future a part 2 where I'll review the commands, but in the meantime, the commands are on the documentation site at AutoControls-dot-WordPress.com. Just look for video number 828 on that page. Thanks for watching.